Hello, Precalculus class. How are you guys? This is our last full week of class. Oh, we are almost finished with our year of Precalculus. Isn't that nice? All right. Well, today we're going to learn some more things about probability. We're going to be talking about what are independent events. And we're probably not going to talk about dependent events today. We'll probably talk about that next time. It's the opposite of independent. We're just going to talk about independent right now. All right. So, what is an independent event? Well, here's the definition right here. All right. The definition says that we say that two events are independent if the occurrence of one event has no effect on the occurrence of another event, all right? Of the other event. All right. So, for example, if I am flipping a coin and J is rolling a die, all right? These two events, we can assume that they are independent. What I get on my coin is not going to change or have any effect on what he does with his die. All right. If I get a heads on my coin, then he is going to roll his die and he's going to get a 1, 2, 3, 4, 5, or 6 with equal probability. Me getting a heads does not change what he gets on his die. And me, if I flip a tails, it doesn't change either. All right. So what I am doing, flipping a coin, and what he is doing, rolling a die, are independent events. They do not affect each other. They have no effect. All right. All right. So we have a rule about independent events. So if A and B are independent events, all right, A and B are independent, then the probability that both of these things happen, so the probability of A and B, all right, which sometimes we also write like this. I usually write it in the shorthand, which is with this little symbol upside down U thing, all right? The probability of A and B, same thing, all right? It will equal the probability of A times the probability of B, okay? So this rule only works if we know that the events are independent. They don't change each other. All right? And this rule applies for multiple events, not just two. Here we have two events, A and B, but what if we have A, B, and C, and we say that they are all independent events, all right? Well, then the probability of A and B and C, which sometimes we would write like this, all right? We would write A and B and C, all right? All right? The probability of all of these happening is the probability of A happening times the probability of B happening times the probability of C happening, all right? So these are rules about independent events. So let's take it back to my example. All right. So if I am flipping a coin, I might be interested in what is the probability that I get a heads. All right. Well, the probability of getting a heads would be 1/2, right? When you flip a coin, the probability of getting heads is 1/2. And then J is rolling his die, all right? What's the probability that he gets, this is heads, what's the probability that he rolls, let's say that he rolls a 6, all right? He wants to roll a 6 on his die. Well, the probability that he gets a 6, I'm going to write the probability of 6 is what? How many different things can he get? He could get 1, 2, 3, 4, 5, or 6. That's 6 different things. And there's only 1 6 on the die. So the probability of him getting a 6 is 1/6. All right. Now, what if I ask the question, what's the probability that I flip a heads and J rolls a 6? All right. So two things happening at the same time, or it doesn't have to be the same time. It could be me go first, him go first. It doesn't matter. All right. But what's the probability that if we both do our thing once, I flip a coin, he rolls a die, what's the probability that I get a heads and he gets a 6? Well, this rule that we just learned tells us that the probability of me getting a heads and him getting a 6 is going to equal this one times this one. So it's going to be 1/6 times 1/2, which is 1/12. All right, so that's how we use this rule of independent events. Now, in order to use the rule of independent events, we have to know, are two events independent? So let's look at some examples, and we're going to make a decision and think, are these independent or not? Or maybe they're dependent, all right? So they could be independent or dependent. So if let's say I toss a coin 3 times. Okay, I'm going to flip my coin. I'm going to go once and then write down what it is, and then I'm going to flip it again and write down what the answer is, and then I'm going to flip it again and write down the answer. All right, so I'm going to do it 3 times. Are these independent events? If I flip a heads my first time, is that going to change what I get the second time? No, it has no effect on it. So, tossing a coin 3 times or many times, doesn't matter how many times, every time we do it, it's an independent event. It doesn't matter what happened before. All right, independent. All right, so this is independent. All right, what about rolling a die twice? If I roll a die once and then I roll it again, does the first time change or affect what I might get on my second time? No, it doesn't. So rolling a die several times they are independent events. Man, I don't know why I'm coughing all of a sudden. All right, so independent. All right, next, what about picking a card? All right, so it says I'm going to pick a card from a deck, look at it, and then I'm not going to put it back in. All right, I'm just going to take another card, a second card from the deck. All right, are those independent events? Now, this time, no, they're not independent. They are dependent. Why? Well, think about it this way. Let's say I want to know what's the probability that I get an ace. Well, if I pick my first card, the probability of me getting an ace, well, there are 4 aces in the deck, and there are 52 cards. So the probability of me getting an ace is 4/52, right? But then the second time I pick a card, my probability is going to be different. And it depends what I got the first time. Think about it. If I get an ace on my first card, ooh, good. And then I want to pick another card, what's the probability of me getting an ace now? Well, there's only 3 more aces left, and there's 51 cards. So now the probability of me getting an ace is 3/51. All right. So the first time it was 4/52. The second time it was 3/51. And if the first time, if I didn't get an ace, all right. Oh, if I get it's a 2. It's not an ace. All right. Well, now when I pick a card, it's going to be a different probability because now there's still 4 aces, but only 51 cards. So now it's 4/51. All right. So it changes depending on what my first one was, right? So that means these are dependent events, all right? All right. And the reason it's dependent is because we did not replace the first card. All right. The second one, D here, all right, says picking a card from a deck, then picking another card after replacing the first card. So if I pick a card from a deck, look at it, oh, it's an ace, and then I put the card back in and pick another card, well, the probability of me getting an ace the second time doesn't change because of the first time, all right? Because I put the card back in, so it's still going to be 4 out of 52, all right? So this time it's independent, all right? So independent, all right? I'm trying to just write it quickly, all right? Independent. All right, so those are the answers. Independent, independent, dependent, and independent. Now, let's look at some examples of how we're going to use independent events. All right, now first, in this one, it says a student is taking a quiz and he randomly guesses the answers to 4 true-false questions. All right, so he's got 4 questions. The answers could be true or false for each one. Here is the sample space. Now remember, what is sample space? Sample space is all of the possible outcomes, all the possible things that could happen, right? So this is the sample space right here, right? And we are going to see it says use the sample space to determine whether guessing question 1 correctly and guessing question 2 correctly are independent events. So let's do this. So let's look at this sample space. What does it mean? It says number of correct 0, and we have I. Well, that means I probably means incorrect, right? So that means the first question we got incorrect, second question incorrect, third question incorrect, fourth question incorrect. And in this one, it says C, I. Well, C means correct, so it's correct, incorrect, incorrect, incorrect. So these are all the ways that we could get one number correct. We could get the first one correct, and then number 2, 3, 4 incorrect. We could get the first one incorrect, number 2 correct, and then number 3, 4 incorrect. We could be incorrect, incorrect, correct, incorrect, or we could be incorrect, 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 correct. So there's 4 different ways that we could get one question correct. All right. Then there's 1, 2, 3, 4, 5, 6 different ways that we could get 2 questions correct. There's 4 different ways that we could get 3 questions correct, and there's only 1 way that we could get all of the questions correct. All right. So we want to know what is the probability of getting question 1 correct. All right. So I'm going to write that like this. I'm going to say the probability of question, I'm going to write Q1. All right, I'm going to say, what is the probability of getting question 1 correct? Well, if we want to know that, we can just count all of the different possibilities that have question 1 correct. All right, well, this one has question 1 correct right here. None of these do. This one has question 1 correct. This one, it's correct, and this one, it's correct. This one is not correct, but this one is. This one is correct, and this one is correct, and then this one is correct. All of these have question 1 correct. How many are there? 1, 2, 3, 4, 5, 6, 7, 8. So 8 of them have question 1 correct. And how many are there total? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There's 16 different possibilities. So the probability of getting question 1 correct is 8 over 16, which is 1 over 2. Okay? Next, we want to see what is the probability of getting question 2 correct. All right, so this is going to be probability of question 2 correct. All right, that's what we're going to do now. Let's see how many have question 2 correct. I'm going to use blue. All right, so here question 2 is I, so it's not correct. But here question 2 is C. Good. All right. No, no, no. Yes, this is question 2 is correct. Question 2 is correct. Question 2 is correct here. Question 2 is correct. Not correct. Correct, correct, and correct. All right. So all of the ones with these blue dots above it have question 2 correct. All right. So let's see how many are there. 1, 2, 3, 4, 5, 6, 7, 8. 8 again. All right. So the probability of getting question 2 correct is 8 over 16, which is 1/2. All right. Good. Now, let's look. It says we want to figure out if we want to use this sample space to determine, are they independent events? Are these independent events? Well, the only way we can know if they're independent is if this is true. We want to know what is the probability of getting question 1 correct and getting question 2 correct. All right. Well, let's see. I'm going to now use green, and I'm going to find all of the ones that have question 1 correct and question 2 correct. All right, so for example, this one has question 1 correct, but not question 2. So I'm going to look for all the ones that has the red and the blue on them. So this, no, 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 no. Yes, this one has CC, question 1 and question 2. No, no. Yes, question 1 and question 2. Yes, question 1 and question 2. And yes, question 1 and question 2. So how many are there that have that? 1, 2, 3, 4. So 4 of them out of the 16 have question 1 and 2 correct. All right, so that's 1 over 4. Now, how do we know if these are independent events? Well, they are independent if this is true. Does P of Q1 and Q2 equal P of Q1 times PQ2? Yes, it does. All right, this equals P of Q1 times P of Q2, right? Because up here it says P of Q1 is 1/2, P of Q2 is 1/2. 1/2 times 1/2 equals 1/4. All right, so it works. All right, so that means yes, they are independent. All right. All right, does that make sense? I hope so. All right, so we can show that they're independent by looking at question 1 and question 2. All right, finding the probability that they both happen and see, does it equal the probabilities of each of them happen multiplied together. All right. So again, this number 4 is similar. All right. So it says over here that a group of 4 students includes 1 boy and 3 girls. The teacher randomly selects one of the students to be the speaker and a different student to be the recorder. All right. So the first student is the speaker, the second student is the recorder. Use a sample space to determine whether randomly selecting a girl first and selecting a girl second are independent. All right. So we want to first find what is the probability that we get a girl first. I'm going to write G1, meaning girl first. All right. Well, let's find all, this is the sample space. All right. Let's find all of the ones that have a girl in the first spot. Well, this one does. 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 But these ones have boys in the first spot. All right. So how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. And how many are there total? 12. All right. So the probability of getting a girl in the first spot is 9 over 12. which is 3 over 4. Next, we also want to know getting a girl second. So what's the probability of getting a girl in the second spot? All right, well, let's see. I'm going to use a different color. I'll use blue here. So let's find all the ones that have a girl in the second spot. Well, this one does. 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 And this one does. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so again, we have 9. So the probability of getting a girl in the second spot is 9 over 12, which is 3 over 4. All right, so we want to figure out, are these independent? All right, are these independent? Well, the way we're going to do that is we're going to find what's the probability of getting a girl in the first spot and getting a girl in the second spot. And we'll check to see, does that equal these two things multiplied together? Well, these two things multiplied together is going to be 3/4 times 3/4, which is 9 over 16. All right. So we want this to be 9 over 16. If it's 9 over 16, that means it's independent. If it's not, then it's not independent. It's dependent. All right. So where are all the ones that have girl 1 in the first spot and girl 2 and girl in the second spot? Girl in the first spot, girl in the second spot. All right. Well, let's see. This one has girl, girl. 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 And this one has girl, girl. These ones do not. So what is that? That's 1, 2, 3, 4, 5, 6. 6 out of 12, which is 1/2. But that does not equal 9 over 16, which is these things multiplied together. Therefore, we know that these are not independent. They are dependent. All right. Dependent. All right. What happens in the first one changes what happens in the second one. And that makes sense, right? If you're choosing 2 and you're not replacing, all right, then if we pick a girl, that's going to change the probability that our second one is a girl, right? So these are dependent events, and we can prove it like this. All right. We'll do a few more examples of using independent events. All right, so we are rolling a 6-sided dice. So we're rolling a dice 2 times. What is the probability of getting the following? Probability of getting a 5 and then a 6. So probability of 5 and 6. Well, what's the probability of getting a 5? Well, there are 6 different sides to the dice, and there's only one side that's a 5, so the probability of getting a 5 is 1 over 6. What's the probability of getting a 6? Same. There's only one 6, and there's 6 different sides, right? So, is rolling a dice 2 times independent? Yes, we already said that. Rolling a dice twice is independent, right? So that means the probability of getting a 5 and a 6 is going to be, so probably a 5 and 6, all right, is going to be 1/6 times 1/6. It's going to be this one times this one, all right, which is 1 over 36. All right, so the probability of getting a 5 and then getting a 6 is 1 over 36. All right, if we roll a die, what's the probability that we get an even number? All right, I'll just write probability of E for even. All right, well, you could get a 2, a 4, or a 6, right? Those are even numbers. There are 3 even numbers, and there are 6 sides to the die, so that means the probability is 3 over 6, which is 1/2. What's the probability of getting a prime number? Well, I'll write that as P and then maybe PR. All right, for prime. Well, what numbers are prime? Well, 1, 2, 3, 5. All right. those 4 numbers are prime numbers, all right? So 4 over 6, all right, which equals 2 over 3. So then what's the probability of getting an even number and getting a prime number, all right, in 2 different roles? All right, well, the probability of getting even and prime, since these are independent events, it's going to be 1/2 times 2 over 3, which is 2 over 6, which is 1 over 3. All right, so 1 over 3 is the answer. Okay? Next, here it doesn't tell us what is happening. It just tells us the probability of event A is 0.3. We want to know what is the probability of B happening, and they tell us that the probability of P and B happening is 0.06. Well, we already know that the probability of A and B has to equal, if they are independent, like it says up here, that means it's the probability of A times the probability of B, right? So probability of A and B is 0.06. And that's going to equal probability of A, which is 0.3, times the probability of B, all right? Which means the probability of B, we're going to have to divide both sides by 0.3. So it's going to be 0.06 divided by 0.3. Okay? And if you calculate this out, you will get 0.2, all right? 0.2, okay? So this is going to be 0.2. All right, easy. All right, last one that we'll do today. Today, we're almost finished. All right, so a spinner with 9 sectors. All right, so again, we talked about this in a previous problem. So we have a spinner. All right, it's got an arrow on it. Then we're going to spin it around, and it's got 9 sections on it. So 1, 2, like 9 pieces of pizza. All right, something like this. All right, 1, 2, 3, 4, 5, 6, 7, 8. Oops, I didn't do enough. All right, 9. All right, and they're equal sized. Now, every time we spin it, it's going to be an independent event, right? If I spin it once, that doesn't, and whatever my answer is there does not really affect what is going to happen on our second one. All right. So what's the probability that I get a 5 and then I get an odd number? Well, the probability of getting a 5, well, there's only one 5 on here, and there's 9 different numbers, so the probability is 1 over 9. What's the probability of getting an odd number? All right, odd number. Well, how many odd numbers are there? 1, 3, 5, 7, 9. There's 5 odd numbers. So there's 5 odd numbers, and there's 9 total numbers. So the probability of odd is 5 over 9. So then what's the probability of getting a 5 and an odd number? Well, it's just going to be 1/9 times 5 over 9, which is 5 over 81. And that's going to be our answer. All right. What is the probability of spinning an even number? So I'm going to write probability of even. What's the probability of even? Well, how many even numbers are there? 2, 4, 6, 8. So there's 4 numbers. And there's 9 total, so it's 4 over 9, all right? What's the probability of getting a 5? Well, we already said the probability of getting a 5 is 1 over 9. What's the probability of getting a 7? Well, the probability of getting a 7, well, there's only one 7. So, again, it's 1 over 9, right? So then our final thing is, what's the probability of getting even, and then a 5, and then a 7? Well, it's going to be 4/9 times 1/9 times 1/9. All right? And you can write that as a fraction. 4 times 1 times 1 is 4. And then 9 times 9 is 81. Times 9 is 729. All right? So 720. So it's 4/729 is the probability. What does that mean? What does 4/729 mean? That means, on average, if I spin this spinner 729 times, then on average, 4 times you will get an E and then a 5 and then a 7 in a row. All right, E5 even, and then a 5 and then a 7. All right. Next, spinning a number greater than 6. All right, so we want to first, I'm going to write probability of greater than 6. Well, how many numbers are greater than 6? 7, 8, and 9, right? So that's only 3 numbers. So it's got to be 3 out of 9, which is 1/3. And then we want to get a not a prime number. I'm just going to write little n and then PR for prime. So NPR means not prime, all right? So what's the probability of getting a not prime number? Well, which numbers are not prime numbers? 1 is a prime number, 2 is a prime number, 3 is a prime number, 4 is not prime, 5 is a prime number, 6 is not prime, 7 is a prime number, 8 is not prime, and 9 is not prime. So there are 4 not prime numbers, all right? So 4, and then there are 9 total numbers. So the not prime probability is 4/9. So then what is the probability that we get greater than 6 and not a prime number? Well, that probability is going to be 1/3 times 4/9, which is going to be 4/27. All right? And that's our answer. Okay, so that's how we do these problems. They're pretty easy, not too hard, all right? Not too difficult. Real quick, I thought I pulled it out. Nope. All right, your homework tonight, I thought I already pulled it up, is right. All right. We're going to be doing this worksheet, and we're just going to do the first page for now. All right, so I wanted to real quick show you what it looks like. All right, so here, the first few problems, number 1, 2, 3, 4, you just need to say, is it independent or dependent events? Are these independent or dependent events? All right. Then for number 5, 6, 7, and 8, it's a word problem, and you need to find the probability. A bag contains 3 red marbles and 3 blue marbles. You pick a marble and then put it in the bag before picking another marble. The first marble is red and the second marble is blue. So what is the probability of that happening? What is the probability of getting a red marble and then a blue marble? Okay? So that's pretty easy. Then look at number 9, 10, 11, and 12. These ones are not very difficult, but I want to make sure you understand what it's asking. All right, so it says probability of A is 11/20. The probability of B is 1/4. The probability of A and B equals 11/100. The question is, are they independent or dependent? So you just need to tell me, is it independent or dependent? All right, and how are you going to know? Well, if this times this equals this, then we know they are independent. If this times this does not equal that, then they are dependent. They are not independent, right? All right, so that's how you do these. You just need to multiply these two together and see, does it equal this? If it does, then it's independent. Okay? That's what your homework is tonight. Pretty simple. It shouldn't take very long. All right, make sure you understand what is an independent event and what is not. All right? That's all for today. I will see you guys next time. Tomorrow, we will have live class. Live class during the 9th period. All right, that's what you guys want, so that's what I'm giving you. Bye.